Hey guys, so I'm here to talk to you about the intermediate value theorem. So this is an idea that 100% will be on the AP test, by the way, and it's a result that I think is extremely obvious, but also extremely powerful, and something that comes up a lot. So I want to build our intuition for it first. If I'm sitting still in my car, and I'm at 0 miles per hour, and then later I accelerate to get on the freeway, and then I'm driving 70 miles per hour. In the time it took me to go from 0 to 70, does there have to be a time in the middle where I was driving 60 miles an hour? Does there have to be a time when I was driving 13.7? Does there have to be an instant when I was driving 24.928? And the answer to these questions is, of course, yes, right? Just like if the temperature goes from 70 degrees one morning to 128 or whatever it's going to be this weekend, it doesn't just jump from 70 to 128, right? It goes through every single temperature on the way from 7 to 128. And that's because those functions of temperature and velocity are continuous. So this is what the intermediate value theorem says. If you have some function f of x, and that function is continuous, and that is crucial, if that function is continuous, and your f of a equals 0, and f of b equals 10. And by the way, there's nothing special about the 0 and 10. I just randomly pick these numbers. This is true for any two numbers you could possibly choose. Then f of x goes through each value on the interval 0 to 10 between x equals a and x equals b. So basically what this is saying is it doesn't skip values. Doesn't skip values. Okay, so let's see if we can kind of draw a picture of what this looks like. Saying okay, we have some function here. It starts at some point a at 0, and then it goes up here to 10 at some point b, where you get up to that point there. So what this is saying is you're not skipping any values. There's got to be some point where you go through 5, and no matter what you do, you're always going to go through 7 and 9 and 2.4 and pi and every single number in the middle, right? You're continuous. You can't just jump over these. That's the intermediate value theorem. One note that I do want to point out is note it must be continuous for this case to be true. It must be continuous for this to work. Because if it's not continuous, right, I could just totally just cheat, right? I can start here at A and I can start at B, so I can start at 0 and end up at 10. I could just go there and then just jump. And hopefully you can see that on your own paper, right? You can skip any point in the middle if it's not continuous by just having a jump or having a hole at that point or whatever. So, I could even go down and then up. I could skip every single value between 0 and 10 if I had a jump if I wanted. So it's got to be continuous, and that is really the key, and that's why we kind of talked about that definition. So there are a couple points or a couple kinds of problems where you'll see this occur on the AP test. So suppose I tell you here's x, here's f, and I give you just a table of data. So I'm not going to actually tell you what the equation is for f, but I am going to show you what it looks like. So this is a table for f, and I say suppose your f of x is a continuous function. And I'm going to have a couple different parts of that. A, does f of x equal 3? So basically, does f of x equal 3? Have a solution on the interval from 1 to 2. Why or why not? Okay, and of course, when they're given in this form, this 1 to 2, these are x values, right? It's saying x equals 1 to x equals 2. It's that section right there. Okay, here's how you want to write this up. You don't need to know the name of this theorem, but the crucial part is mentioning that this is continuous. And when you're writing this up on the AP test, you have to say that your function f is continuous. So you're going to say it like this. You're going to say, okay, f of x is continuous. And let's see, so we're starting at 2, we're going to 5. So don't I have to go through 3 in there? Yeah, that's what the intermediate value theorem guarantees. So f of x is continuous, and f of 1 equals 2, and f of 2 equals 5. So f must go through 3 on this interval from 1 to 2. Yes is the answer to the question. Okay. So that's how you approach it. Now, if I had asked you about the interval 2 to 3, like, I don't think we can draw a conclusion, right? If it goes from 5 to 4, like, maybe it goes through 3, but it doesn't have to. It might just kind of go down in a straight line from 5 to 4. It might dip down and hit 3, but it might not. So we're going to kind of try and just avoid that one. Okay, so keeping that in mind, that's how we'd answer a question like this. Let's try another part of this problem. Basically, just say at least, I'm going to expand this a little bit, at least how many times on the interval 0 to 4 must f of x equal 0? Okay, so how many times do we have to have a height of 0? Okay, so again, I'm looking for like changes. As I go from -5 to 2, I have to go through 0. Yes. 2 to 5, maybe not. 5 to 4, maybe not. 4 to -1, yes. So I see on the interval 0 to 1 and 3 to 4. So I think I'm going to say at least twice. Like, maybe it happens again from 2 to 3. It might go from 5 to 0 to 4. But it has to happen at least twice. At least twice. And again, the way you want to write this up, you want to cite that you have a continuous function. So f is continuous. And must go through 0 on the two intervals. So that would be on 0 to 1 and then 3 to 4. 0 to 1 and also the interval from 3 to 4. Okay. And you could, it wouldn't hurt to give those values, but that's fine too. Okay, so that's that kind of problem. The other kind of thing where you'll see maybe someone gives you an equation, and obviously this is one you don't have a graphing calculator for, but r of t equals t cubed minus t squared plus 2t plus 4. And the question might ask, does there have to be a time? Does there have to be a time on the interval from 0 to 2 where r of t must equal 8? And then why or why not? Okay, so the things you want to ask yourself is, first off, is this continuous? Well, yeah, right? There are no problems. There's nowhere where you have to divide by 0 or undefined or anything. So r of t is continuous. So that's our first check. Now, one thing that I might want to do, you can't just plug in all the infinite points between 0 and 2. So I think the best starting point is to check the endpoints. So just check x equals 0 and x equals 2. So r of 0, of course, is 0 minus 0 plus 0 plus 4. R of 0 equals 4. Okay. And then r of 2, that's the other endpoint. So let's see, we have 8 minus 4 plus 8 plus 4. Okay, let's see if I did that right. So that's going to be, 2 times 2 is actually 4. Good thing I'm a moron. So this turns out to be 12. So, okay, yeah, if we go from, 4 to 12, do we have to go through 8? Yeah. So again, the way you write this up is you say, okay, r of t is continuous, and r of 0 is 4, r of 2 is 12, so r must go through 8 on that interval from 0 to 2. They're pretty picky about this on the AP test, but this is kind of an example of how you want to write this up. Okay, that's intermediate value theorem. Hope this helped, and I'll see you guys soon.